FastMCP 3 introduces a composable lifespan mechanism that enables precise control over server initialization and teardown sequences, ensuring resources are properly managed across the application lifecycle. This pattern leverages asynchronous context managers to encapsulate setup and cleanup logic, allowing for modular integration with existing FastAPI applications. We are about to examine how a FastMCP server is instantiated with a designated identifier and how its HTTP application is mounted within a FastAPI instance, while combining their respective lifespans to maintain coherent startup and shutdown behavior. The code will reveal the use of combined lifespans to merge the FastAPI application's lifespan with that of the FastMCP server, ensuring both are executed in the correct order during server initialization and termination.
From context-lib import, async context manager. From FastAPI import FastAPI. From FastMCP, import FastMCP. From FastMCP, utilities, lifespan import combine lifespans. Add async context manager. Async def app lifespan app. Print FastAPI starting. Yield. Print FastAPI shutting down. MCP equals FastMCP tools. MCP app equals MCP. HTTP app. App equals FastAPI lifespan equals combine lifespan SAP lifespan. MCP app. Lifespan. App mount /MCP. MCP app.
This code demonstrates how to integrate FastMCP with an existing FastAPI application by mounting the MCP server as a sub-application. The pattern uses FastAPI's mounting capability to combine both servers under a single endpoint structure, with the MCP server accessible at /MCP. The integration handles lifespan management through combine lifespans, which merges the FastAPI application's lifespan with the MCP server's lifespan. This ensures both the main application's startup shutdown logic and the MCP server's initialization cleanup processes execute properly. The App Lifespan Context Manager handles FastAPI-specific startup and shutdown tasks, while the MCP server's lifespan is automatically managed through MCP, HTTP app. This approach provides a clean separation of concerns while maintaining unified server management. The MCP server operates as a distinct module within the larger FastAPI application, allowing for modular development where MCP functionality can be added to existing web services without restructuring the entire application. The lifespan composition ensures proper resource management across both systems, which is particularly important in production environments where cleanup operations must execute reliably. Let's break it down.
From context-lib import, async context manager.
Imports the async context manager decorator from Python's context-lib module, which enables creating asynchronous context managers for resource management in async code.
From FastAPI import FastAPI.
Imports the FastAPI class from the FastAPI package, which is a modern web framework for building APIs with Python.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which is the primary class for creating MCP servers.
From FastMCP, utilities, lifespan import combine lifespans.
Imports the combine lifespans function from FastMCP's utilities module, which merges multiple server lifespan handlers into a single composable lifespan.
Add async context manager.
Imports the async context manager decorator from Python's standard library, which transforms a generator function into an asynchronous context manager for use with async with statements.
Async def app lifespan app.
defines an asynchronous function named appLifespan that takes a single parameter app. This function signature indicates it will handle server lifecycle events for the provided app object, executing setup and teardown logic during application startup and shutdown.
Print FastAPI starting.
Prints the string FastAPI starting to standard output, indicating the FastAPI application is initializing. This is a simple status message for debugging or monitoring purposes during server startup.
Print FastAPI shutting down.
Prints the string FastAPI shutting down to standard output, indicating the FastAPI application is in the process of shutting down. This is a simple logging statement that outputs a shutdown message to the console.
MCP equals FastMCP tools.
Creates a FastMCP server instance with the identifier tools that will be visible in MCP protocol handshakes for client identification purposes. The string parameter serves solely as a server label and does not configure any functional behavior or operational mode.
MCP app equals MCP. HTTP app.
Creates an HTTP application instance using the MCP module's HTTP app function and assigns it to the variable MCP app. This line initializes the core web application object that will handle HTTP requests according to the MCP protocol.
App equals FastAPI lifespan equals combine lifespan lifespan. MCP app lifespan.
Creates a FastAPI application instance with a combined lifespan that merges the application's own lifespan app lifespan with the MCP server's lifespan MCP app lifespan. This ensures both the FastAPI application's startup shutdown routines and the MCP server's initialization cleanup processes execute when the server starts and stops. The combine lifespans function merges these two lifespan contexts into a single handler passed to the FastAPI constructor.
App mount/MCP. MCP app.
Mounts the MCP app FastMCP server at the /MCP path, making all its components and endpoints accessible through the parent application under that root prefix. This creates a modular composition where the mounted server's functionality becomes available as a nested service. The key takeaway here is how FastMCP3's composable lifespan mechanism enables clean integration with FastAPI through modular composition. By leveraging combined lifespans, we merge the FastAPI application's startup shutdown logic with the MCP server's initialization cleanup routines into a single coherent lifecycle. This ensures both systems initialize and terminate in the correct order while maintaining separation of concerns. The pattern mounts the MCP server as a sub-application at /MCP, making its functionality available through the parent FastAPI app while keeping the MCP server's components encapsulated. The app lifespan context manager handles FastAPI-specific operations, while the MCP server's lifespan is automatically managed through MCP, HTTP app. This modular approach allows adding MCP capabilities to existing web services without restructuring the entire application, with proper resource management across both systems.
The lifespan decorator pitches its tent, while the server spins components into existence before the first spectator appears.